Okay, so yesterday we talked about two proportion um, confidence intervals. Okay, comparing two proportions together, comparing two samples together. Excuse me. That's why we do two. That's why we do two sample, right? Today we're gonna do the same thing except now tests, right? Now test. So it's two samples we're trying to compare against each other. When testing the hypothesis that there is no significant difference or significant change between the population. So I'm comparing two populations. Is one significantly higher than the other? Or is one significantly lower than the other? Okay, I'm comparing those two, and I use the samples to compare the populations. Okay, so today we have significant evidence to show that this sample or this population is better than this population at something. Or we don't have enough evidence to say there's a difference between the two. Is there a difference? Might be, but we just don't have enough evidence to say there's a difference. Okay? So the null hypothesis will always be the same. The null hypothesis will always be the same. It's written right here. So for all of these, the null hypothesis is always going to be P1 is equal to P2. P1 is equal to P2. Means there's no difference between the proportions. There's no difference. That's always going to be our null. Always, that's the claim we're trying to disprove, right? Because if we can disprove it, that means there has to be a difference, right? Okay. Um, parameters, assumptions are all the same as yesterday. Nothing that hasn't changed. Pooling, something that only happens on this test, is called pooling. Pooling is when we combine samples. Okay? We combine samples because sometimes one sample is a lot bigger than another sample. And if that's the case, they kind of outbalance each other. So, for example, let's say one sample. Now, this is for like dramatic purposes. I'm not really saying this will happen, but let's say one sample was 1 out of 2, and the other sample was 30 out of 50. Right? The first one is 1 out of 250, right? 50%, 0.5. The second sample is 0.6, right? But which one is going to weigh heavier? Which one is going to weigh heavier in the final calculations? Sample 1 or sample 2? Oops. Sample 1 or sample 2? 2. Why 2? Yeah, you're right. Why 2? N is a lot bigger, right? So it's not fair to compare these two samples when this N is a lot bigger than this N. So what do? We do what's called pool them, combine them. So it's really easy. You add the two samples, so 52, add the two tops out of 31. So if we were going to combine them, we would say 1 plus 30 over 2 plus 50, which is 31 over 52. And that's the one we'd use so that one of them doesn't outweigh the other. Okay, because we want them on a even scale as much as possible. Okay, this is the only time we pool. Every other time we don't pool. Two proportion z-test is the only time. Okay, in fact, your calculator will ask you today, do you want to pool? Today is the only time we're going to. With this test right here is the only time we do that. Okay, not even with intervals like we did yesterday. We don't do that. Okay, so that's when you see PC, P sub C, it means the pooled, the combined sample. Okay. Okay, so here's our test statistic. The bottom should look familiar. Besides the C, it's the same one we used yesterday, right? It's where is it? This guy, right? right? But instead of 1 and 2, we use C, the pooled one. Okay, so that one is the same. What do we do on top? We just subtract, right? Just like we did yesterday. Subtracted, right? We do the same thing for the z-score. We just subtract on top, standard deviation, formulas on the bottom. Okay, and then the pooling part. We talked about the pooling part. And then everything else is the same. Everything else is literally the same. Our conclusion is going to be, since our p-value blank is less than or equal to alpha, we fail to reject the null hypothesis. We do or do not have sufficient evidence that, same thing as you guys just did on that last test. That hasn't changed. Okay? So let's look at one. Let's look at one. So jump ahead a couple pages to the third example, the last example, the very last example. Researchers designed. Okay. So researchers designed a study to compare the proportion of students who come to school without eating breakfast among freshmen and sophomore students at Central High School. Okay. An SRS of 80 students from the sophomore class found that 19 of them missed breakfast that morning. Okay. An SRS of 150 students from the freshman class included 26 who missed breakfast that morning. Okay. More than 1,600 students attended. This is back when this data was gathered when we were combined with East Campus. So we were one school with East Campus. So if you guys remember that, we had a lot of freshmen. Like half our students was freshmen. We had a ton of freshmen. And then we had some sophomores, juniors, and seniors, but not as many, right? So that's why the sample of freshmen is bigger, because we had more freshmen. Okay? Now it's more balanced. Okay, so this is when the data was gathered. We have about half the students on our campus here. So this numbers, right now we have about 800. So this was back when we were one campus. Now we split, so it's different. But that's when this data came from. Okay, so more than 1,600 students attended CHS West. Do the data give convincing evidence of a difference in the population proportions at 5%? Okay, so we're comparing two populations. We're comparing two separate populations. So let's identify them first. First thing we got to do is identify them. Okay, so what I'm going to do is I'm going to put, yesterday I did 1 and 2, right? P1 and P2. Today I'm going to label one as freshmen and one as sophomores. You can do 1 and 2, or you can label it. The reason sometimes I label them like this is because it helps me remember down the road when I'm trying to do formulas. Because sometimes you're like, which one was P1 again? Which one was P2 again? You can use P1 and P2. That's okay. There's nothing wrong with it. But when I use those little markers there so that I can, freshmen, PF freshmen, PS sophomores. Okay. Okay, so true proportion of, since this is F, we're going to say freshmen at CHS who missed breakfast. Who missed breakfast. That's what that would tell us, right? Do we have a sample from that guy? Do we have a sample? That's the true proportion, right? I don't have that number. I don't have the true proportion of all freshmen who missed lunch or breakfast. But we do have a sample, right? So we're going to label that as well. P hat F. What proportion is that going to be? What proportion is that going to be? What are we going to use for that proportion? 26 out of 150, yeah. 26 out of 150. which is around a little over 17%. Okay. All right, now let's do PS. This one's going to share a lot of the same stuff, right? There's not many words in that sentence that are going to change for P sub S, right? It's still going to be true proportion of, this one's going to be sophomores at CHS who missed breakfast, period. That's the only difference. And we have a sample of them too. Right? We have a P hat S. Right here. 19 out of 80. 19 out of 80. Okay. So those proportions are different. So what we're doing is we're testing to see if those proportions are significantly different. I know they're different. I know this one is smaller than this one. I know that, right? One's about 17%, one's about 24%. But we're trying to see if that's significant, because we're not trying to make decisions on the sample. We're trying to make decisions on everyone, on all the sophomores, on all the freshmen. Okay? So that's what we're trying to do here. Okay, so there's that. Next step, hypotheses. The null hypothesis will always be that the true proportion of the first one is no different than the true proportion of the second one. They will always be equal for the null. The null means they'll always be equal. For the alternative, I have three options: greater than, less than, not equal to. So reading the question, which one am I going to choose? Not equal to, yeah, because it just says evidence of a difference, right? It just says evidence of a difference. Doesn't say one's bigger than the other. So we're just going to choose not equal to. Significance level. It said use 5%. Okay. 3. The fourth thing we got to do is our conditions assumptions. So we're going to have 3 columns here. 1 column for the actual condition, 1 column for the first sample, 1 column for the last sample. So conditions, check PF and check PS. Okay. 10% condition. Oops, no, 10% condition goes second. SRS goes first, yeah. Okay. So let's see, how was each sample gathered? It does say SRS for each. SRS of 150, SRS of 80. So we say stated. Okay, number 2. N is less than or equal to 10% of big N. Okay, for freshmen, there was a sample of 180 or 150. I don't have the numbers of freshmen that year. Whenever this data was taken, I don't have the total numbers of freshmen. So I can't do that other than say all freshmen or all ninth graders? Okay. Same thing with sophomores. I don't have the data on how many sophomores there were that year where the data was taken. So I'll just say all sophomores or all 10th graders. Okay. Last one is shape normal. Okay. So n times p is greater than or equal to 10. Let's see if I make this a little smaller. Oops. And 1 minus p is greater than or equal to 10. Okay, so n in this case for freshmen, n was 150 times p, which is, we're going to use p hat for that one. So we're going to have 0.17. And then 150 times 1 minus 0.173. For this one, I get 25.95 is greater than or equal to 10. And this one, I get 124.05 is greater than or equal to 10. So they both check out there. Okay. Let's see, this guy over here, this sample is smaller, so I think it was 80. 80 times 0.2375. And 80 times 1 minus 0.2375. So I get 61 for one of them and 19 for the other. Okay, good there. Okay, so we got 7 things to do. We've done 4 of them. So we got 3 more. Test statistic. Which formula are we going to use? Well, we're going to use the one we just saw a little bit earlier. We are going to use this guy right here. And we have to calculate. So when we do calculations, we're going to have to calculate P sub C, the combined pooled. We still haven't done that, but that's the guy we're going to use. Subtract on top. On bottom is the standard deviation formula. Okay, calculations. Okay, so Z equals, let's see, freshmen was 0.73 minus sophomores, which was 0.2375. Then I have to calculate the combined, the pooled one. I haven't done that yet, so I'm going to do that right now. So I take the top number from the first one. The top number from the first sample was 26. So I'm going to go 26 plus 19 on top. And the bottom, I'm going to add the totals, the ends. 150 plus 80. So I get 45 on top. $230 on the bottom, which makes a pooled 196. 196. That's the number I'm going to use. 0.196. 1 minus 0.196 over N1, which was 150. Plus 196. 1 minus 196 over 80. Okay. Again, you can calculate that by hand. It wouldn't take, not by hand, but using like a regular calculator, you could do that. It's not anything you can't do. All you need is multiplication, division, addition, and square roots. But since we have the calculators, we can use a faster method. Okay. So we're going to go find what test to use. So we're going to go stat tests like we always do. And we're going to go pick a test. We want a test, not an interval like we did yesterday. We want a test. So we go to stat tests. So the first 6 are tests. The first 2, 1 and 2, are one sample. We don't want that. 5 is one sample. We don't want that. So we either want 3, 4, or 6. And 6 is the only one that says proportion. That's the one we want. So we go 6. And then now I have to put in the first 2 samples. So the first sample was freshman. Okay. Freshman sample was 26 out of 150. So I'm going to put 26 over 150. The second was sophomores, 19 out of 80. Not equal to. And then I'm going to hit calculate. And then it gives me all that stuff. So first thing it gives me that I need is my z-score. Negative 1.6, negative 1.17, we'll say. Then we have to draw our picture. We didn't draw our picture earlier. We have to draw our picture for tests. When I draw my picture, what's the center going to be? So when I draw my picture, what is the center going to be? Not the combined, you're close. It's the claim, right? What was the claim? They're equal to each other, right? And if they're equal to each other, what's the difference? 0. That's the center. Zero will always be the center for any two sample. Anything 2 samples, 0 is always the center. Here's my next question. What value are we going to choose on here? So where are we going to put one of these guys, right? We're going to do this, right? Or over here, right? And then we shade based off of that. Where do we come up with that guy? That guy is always based on the sample, right? So to come up with that guy, we're going to subtract the top. We're going to do this guy here. I'm going to subtract the top. It's going to be a negative number. So I'm going to subtract the 2 p hat freshmen minus p hat sophomores. Negative 0.0645. So negative 0.0645. Okay. Now, which way am I going to shade? Less than, greater than, both? So for this one, I'm going to for sure shade less than. But it's going to be two-tailed because we chose not equal to, right? So my other tail is going to come from the distance, right? The distance from here to here is 0.0645. So that means the distance here is going to be the same distance, except positive, 0.0645. Okay. Yes, yes. Anytime you're dealing with two sample tests, any two sample test, since the null hypothesis is always that they're the same or there's no difference, it's always going to be 0. Yeah, for two sample. For one sample, it's not the case. But for two samples, 0 is always going to be the center. Okay. Okay, so the p-value. I calculated the p-value. I just didn't write it down. All right, so the p-value was 0.2427. 0.2427. The one right below the z. That's the p-value. Okay. That's both. When the calculator gives you a p-value, that's everything. So if it's a two-tailed, it's both tails. If it's a one-tail, it's just the one tail. Okay. Okay. Here's my question. I chose to do freshmen minus sophomores. Could I have done it the other way? Could I have done sophomores minus freshmen? So I chose the first p hat as freshmen. Second one as sophomores. My question is, could I have flipped those? Would it have been okay to flip those? The answer is yes. It's okay because it's a judgment. It's not anything. I could have, right? That means these two numbers would flop too, right? That means these numbers would flop, right? How would that affect my p-value though? Or would it affect my p-value? It wouldn't, right? Because if I were to flip these guys and calculated it, I would have gotten that. I would have gotten this guy right here. Positive, right? As opposed to the negative one that I did get. So it's always going to work out. Even if it was one-tailed, it would still be okay. When is it going to matter? In our conclusion. When we write our conclusion, we're going to say, we're going to talk about that. Okay. So let's write our conclusion. Same conclusion, same sentence frame as you guys did on your test. on your test from last week that you got back today? Okay. So since p-value, which was 0.2427, is greater than alpha 0.05, we fail to reject the null hypothesis. Means we can't say that they're not different. Kind of sounds weird when I say that, but that's essentially what it is. The null hypothesis is that they're the same. There's no difference. We can't reject that. So we don't have enough information. We don't. So therefore, we lack sufficient or enough evidence or significant evidence to suggest that, and then we're going to go back to the alternative. We're going to put that in words. We're going to put this guy in words. That the true proportion of freshmen who miss lunch is different than the true proportion of sophomores who miss lunch. Or something along those lines. Therefore, we lack sufficient evidence to suggest that the true proportion of those who missed lunch, or breakfast, why do I keep saying lunch? It's breakfast. We lack sufficient evidence to suggest that the true proportion of those who missed breakfast differs from 9th to 10th graders. We can't say that the true proportion is different. It's not significant enough. So even though there were more freshmen, even though there was a higher proportion of freshmen who missed missed breakfast, there was a higher proportion. There was in our sample. We can't say that for the entire population. We lack sufficient evidence to suggest that the true proportion of those who miss breakfast differs from 9th graders to 10th graders. Okay? Even though those are different. You had a higher proportion of sophomores who miss lunch than freshmen. But that's just the sample. The sample there wasn't a big enough difference in the sample to say to allow me to say it for all freshmen and sophomores. Okay. That's what a test does. Same as last chapter. Okay. All right. Is there another part to it? No, that was it. Okay, so one more thing and we're done. So go to the third page, I believe it's the third page. The third page. Sampling distribution. So a sampling distribution means when I take a bunch of samples, lots and lots and lots and lots and lots of samples, just like we did. Remember we did this a little over a month ago, when we got a lot of samples of it was LeBron James points, and we put them all on the circle over there. We had them all listed, right? That's a sampling distribution. When I do that an infinite number of times, okay? When I take lots and lots and lots of samples, right? So when I take lots and lots of samples, comparing the two, right? It's approximately normal if the first dot we've already done, right? The first dot is our condition number 3. First dot is condition number 3. We've done that already, right? We know how to do that, in other words, all right? N times P is greater than or equal to 1. N times 1 minus P is greater than or equal to 10, sorry. Okay? The mean, the average of all of those in the circle. How do I know what the average is going to be? Well, you subtract P1 minus P2. Subtract P1 minus P2. Okay? The standard deviation. Well, this guy should look familiar here. We just used it, right? So the standard deviation for all of the sample distribution is that guy there. We use that one. Okay. So let's look at the first example that we skipped. Okay. In a very large high school, the junior class has 800 students. Okay, very large high school. 54% of whom are female. Okay, the senior class has 70%, 700 students. 49% of them are female. The student council selects a random sample of 40 juniors and a separate random sample of 35 seniors. So let P hat sub junior minus P hat sub senior be the difference in the sample proportions of females. Okay? So what is the shape of the sampling distribution for P hat juniors versus P hat seniors, and why? Okay, so what is the shape going to be? Well, that's number 3, condition number 3. If it meets condition number 3, we say it's approximately normal. If it doesn't meet condition number 3, we can't say. We don't say not normal. We just say we can't say due to it failing condition number 3. Okay? So I want you to check condition number 3. Do that first example. Is it approximately normal? So P for the junior class is 54%. So we want to check this. Do we want to check to make sure 800 times 0.54 is greater than or equal to 10? And we also want to check that 1 minus. And then we want to do the same for the senior class. Their sample was 700. So 700 times P, which is 49. And 700, 1 minus 49. First one, I get 432 is greater than or equal to 10. That works out. And then this one is 368, greater than or equal to 10. This one over here is 343. $357. So yeah, what is the approximate shape? We would say, let me get another sheet of paper. I'm running out of room here. We would say shape for sampling distribution of p hat junior minus p hat senior is approximately normal. And then our justification is this guy, is this right here. That's our justification. Mm-hmm. Let's see. Ends 35. Oh yeah, you're right. No, that's right. I did it wrong. Yeah, I put the total number. I put big N. I needed to put little n. So yeah, so it wouldn't be 800. Yeah, that's a big mistake. So 40 and 35. So let me change that. This should be 40. And this should be 35. Yeah. 40 times 0.54, 21.6. And this would be 19.4. 17.15. 17.85. There we go. Yeah. Luckily, it still works out. So my answer doesn't change, but my justification does. Yeah, for sure. So yeah, so if I answered this question on a test, I'd only get half credit. I got my justification right, but I didn't get my calculations right. So yeah. Okay, so the mean. So it says the mean of a sampling distribution is the true proportions. If you subtract the true proportions minus each other, that's where we're going to use the true proportions. So P for the junior class is 0.54 females. P for the senior class is 0.49. So we're going to subtract 0.54 minus 0.49, and we're going to get a difference of 0.05. Probably should label that a little better. Okay. Standard deviation. Standard deviation. So standard deviation, we're going to use this guy right there. Okay. So standard deviation, p hat junior minus p hat senior equals P1 is juniors, so that's 0.54. 1 minus 0.54 over N juniors, which is 40, plus 0.49 times 1 minus 0.49 over 35. Okay. divided by 40. 0.49 times 1 minus 1.9 divided by 35. Add that guy, 0.00621. Take the square root of that, and I get double check my math to make sure I got the right thing. I think I got the right thing. All right. And that is it. 10.2 is almost exactly the same, literally. You're going to have 3 questions. This is going to look the same. The only difference is it's means, averages, instead of proportions, or t-tests and t-intervals instead of that. But that guy's going to look very similar. That guy's going to look very similar. Okay? All right. We'll do that. We'll start that on Thursday. Tomorrow, like I said, I'll give you your assignment, give you time to start that.